Hello, scholars. Can you hear me? Hello, can you hear me?
Yes, we can hear you.
How are you guys doing? Um,
Good. How are you?
Fine, thank you. So, we are now in a new chapter. So we'll be looking at actually you're now in module 6, confidence intervals. Look at my announcement. You will see what will be assignment that I teach chapter to read. And when you read those chapters, read only the ones, those section of the chapter that we cover in this class. You don't have to read the whole chapter. Well, I mean, of course, you can explore. Yeah, can explore. But as but make sure that you read only the areas that we cover in this class because that's where the questions will come from. Now, the assignments for this week, for this chapter, where I will say it's for this chapter. Homework 8 is due on November 23rd. Classwork 8. Even I wrote due today, but I have to change it. Yeah, because I want to finish grading the other one before I can give you this one. So don't worry about this classwork here, classwork 8. Test 2 is due on Sunday, the 23rd. Um, which should be yeah, not this Sunday, but next Sunday. So you have enough time to. By that time, hopefully by that time I'll put the review practice questions for you. So you can use the review. So we are now in a new chapter called chapter 8, and we'll be focusing on confidence interval. So I wrote a mistake. This is my mistake here. So it's a confidence interval. Let me correct this mistake. With confidence intervals, not normal distribution. So confidence intervals. Okay. Confidence intervals. Intervals. Yeah. We'll get it. Okay. Hmm. We're here anyway, so all right. So I have this. Two more people came in. Road cloud. Uh, Major, right? Yep, coming. All right, so that's where we are. By next week, I will set up your project, your final project for this class. Is there anybody in this class who is graduating? Hello? Can you hear me, guys? Hello, can you hear me?
Yeah, we can hear you.
Is there anybody in this class who is graduating this semester? So nobody. Okay, good. Excellent. Excellent. So now, of course, you can have access to these assignments here. Click on the modules and scroll down to module 6. This is test 2. This is homework 8. It's classwork. Like I said, don't worry about the classwork 8 now because, like I said, I want to finish grading the last 2 I gave you before I can give you this one. Okay. Um. Now let's begin. Confidence interval. That's what. So confidence intervals. Now, confidence interval. A confidence interval simply means uh, an interval that gives an estimated range of values. Make sure you can see this very well. Make it make it probably 18 would be better. Good. That's better for you. Yep. So it gives an estimated range of values, which is likely to contain or to include an unknown population parameter. And this estimated range, we calculate it from a given set of sample data. For example, like I wrote on the screen, a confidence interval for mean is a way of estimating the true population mean. So instead of a single number for the mean, we use two numbers, a lower number and a lower number or a lower estimate and an upper estimate. Okay. So and when I say population parameter, I know I have explained this at the beginning of the semester.
Excuse me?
Yes, ma'am.
I have a question.
Go ahead.
Is this the classwork we're supposed to be doing or no?
No, I didn't say that this is classwork. I'm just teaching confidence interval topic.
Okay, thank you.
Welcome. So now the population parameters. The population parameter is like things like the mean, standard deviation, and proportion. So when I say the population parameter, so you know that those are what I mean. A number that describes population. A numerical estimate of a population I can bring these people in. So mean, median, mean and standard deviation, and then proportion. Okay. Now, for confidence interval, we have the upper and lower value for that. And then also, instead of using one single number, we use a range of numbers, the upper, lower estimate, and upper estimate. Like, let me show you. All this time we have been calculating the mean and standard deviation. We're using what we call a point estimate, which is a single numerical value estimate of a population parameter. For example, a bus driver may claim that the average price of gas in 2022 is $3.67 a gallon. See, that is one number. We call it a point estimate. Also, at something like Ford CEO might say that the company produced on average 200,000 cars in 2013. See, again, one number. Now, but for interval estimate, we use two numbers, lower estimate and the upper estimate. For example, the same bus driver can say that the average price of gas in 2022 was between $3.50 to $4.50 because it fluctuates. I want you to take note of this in average. This is the parameter we are talking about here. Average, just mean. So you have to include it in your estimate. Otherwise, that'll mess up your answers. So Ford CEO can also say that the company produced on average 190,000 cars to 250,000 cars in 2013. So that will give you an idea of what an interval estimate is. Before we can start calculating confidence interval, there are some few terms we need to know. Excuse me. One of them is the confidence level. Confidence level means the likelihood that the true population parameter, such as the mean or the standard deviation, lies within the range specified in the confidence interval. So in statistics, there are three most common confidence interval we use: 90% confidence interval, or 90% confidence level, 95% confidence level, and 99%. So if you are 90% confident, that means your chance of you being wrong is 10%. If you're 95% confident, Your chance of you being wrong is 5%. And if you, of course, if you're 99% confidence, what I do here. Can you hear me? What happened? Okay. So if you are 90% confident, I mean 99% confidence, the chance of being wrong is 1%. So nobody can be 100% confident. Only Providence can be that. So in statistics, we recognize that. Even a DNA test, even if the kid is your kid, they will tell you 99.99% confident that this is your kid or not your kid. They can never tell you 100% because that's you have to make room for human error. Now, another thing we need to get is the critical value. See, this is the value on the borderline that separates the sample statistics that are likely to occur. So we get it either from the table, or we were using a software like Excel, application software like Excel. Since we started this with Excel, so let us just continue with it so that you will not be confused. It's called Z alpha over 2. Why alpha over 2? Because you have to remember it has two sides, the lower estimate and the upper estimate. So there's one quick formula I use, this one here, but like I said, we're not using table now, we're using Excel. That will make us to be faster. So the first thing you need to learn is how to find critical values. Yeah, when you're doing confidence interval computations, first thing you need to know is how to find critical values, because with that, you can find the error, the margin of error. So let's see. Look at this question here. It says, find the critical alpha and the critical values. Find the critical alpha and the critical values using the information on the table below. Then complete the table. Basically, it gave you some confidence levels, and it asks you to find the alpha and the critical value. So to make it easy for us, I'm going to put this in Excel, and I'll show you the formula we can use for that. Okay. I'm going to take it to Excel. It will reduce our time. So I'm going to put this right here. And I'm going to make it is too big. I'm going to make it to be, I think it's good enough. So these are the confidence level. This is the alpha. I think that this can show us alpha. Let me see if I can put alpha from here. Let me make sure you're seeing this first of all. Yep, you're seeing it. You know, alpha, which is on the symbol. Put the alpha to be this. Insert. That's an alpha right there. Oh, excuse me. Then Z alpha over 2, that's confidence, a critical value. Z alpha over 2. This is two sides. Okay. Alpha over 2. Okay. Over 2. Probably make this so you can see them clearly. Yeah. To have the confidence level, like I said, if you're 90% confident, I mean, your chance of being wrong is 10%, which is 0.1. And if you're 95% confident, your chance of being wrong is 5%, which is 0.05. If you're 99% confident, your chance of being wrong is 1%, so your alpha is 0.01. If you are 98% confidence, your chance of being wrong is 2%, which is 0.02. With this, now you can find a critical value. Let me show you the Excel formula we'll be using. I'm going to write it down here so you can see it on the text box below. The Excel formula is, I wrote it down somewhere. No, of course, you do know that you have to put the equal sign first. Oh, excuse me. Norm dot S dot inverse. Okay. 1 minus alpha over 2. Alpha over 2. Alpha over 2. Okay. Alpha over 2. We'll make it bigger so you can see the formula, Excel formula you can use. Oh, excuse me, sorry. That's better. Make it bold. That's right there. So let's do it. Ready? Let's do it. Good thing about Excel is if you do one of them, you can copy the formula down. It will get all the critical values for you. So the first one equals norm dot S dot inverse. That's going to be inverse. It pops out. 1 minus alpha. First one is alpha is 0.01 over 2. Forward slash is, it means division, yeah. But 2, close it. Then press the enter key. See? And then you can just copy it down. It will calculate the rest of them. Normally we leave it in 2 decimal places, so we can just change it to 2 decimal places. See, you have done it for all of them. Now, if you are using table, this will take you a while. Any question on this? Any question, guys? So no question. So I'm gonna make it good, and then I'm gonna copy it and paste it in our main workbook where the question was asked. So this is our answer here, solution. Solution. Make the solution to be 18. So answer right there. I'll bring it down here. So make it 18 as well. Yeah, 16 is good enough. So that's the answer. We have it. So each time I ask to find the confidence in critical value, just use the method I just showed you. And this question, like for example, now this question says find the critical value z alpha over 2 corresponding to 92% level. And this one says to 74% level. Just go there. You can just go to the table we have here. Excel. Okay. Put 92% here. 92%. 90%. Yeah. And here it will just that means the chance of being wrong is 8%, which is 0 point. Okay. It will calculate it automatically. And if you put 74%, the chance of being wrong would be let's see. Maybe a calculator will help us to find that. Chance of being wrong, maybe. Let me find my calculator. Okay, where is my calculator? It's going to grab it somewhere. Okay, right here. Will be 100 minus 74%, 26%, 26%. So your chance of being wrong, 26%, be 0.26. And that will give us critical value of 13. So just use this formula, you get it right away. Now move to the next thing. that we need to know when we do confidence interval is to how to find the margin of error. Now, let's look at the steps. You can ask to find let's start with the confidence interval for the mean for a scenario where this is obtained. The first case is here, where the population standard deviation is known and the sample size is greater than 30. That means for large samples, the steps are as follows. Find the critical value. I just showed you how to find it. Find the error margin using this formula here. For us, we'll be using Excel. So then find the confidence level. Find the confidence interval. That means using this formula here, X bar minus error, then S bar plus error. So on the left side, you subtract the error. On the right side, you add the error. Remember, the best point estimate of the population mean is the sample mean. Let us try one example here. Okay? Look at this question. It says, a sample of reading scores of 35 fifth graders has a mean of 82. The standard deviation of the population is 15. Find the 95% confidence interval for the mean reading scores of all fifth graders. B, find the 99% confidence interval of the mean reading scores of all fifth graders. So you have to find 95% and then 99%. So this, like I said, there's a way we can do it using the formula method and then the table. But for us, we'll be using Excel, making it to stand out. So let us find it. First thing we need to know is to write out our values. The X bar, the mean, won't allow me to put it here. So I'm going to write it. It's an example of reading scores of 35 fifth graders. So N is 35. First of all, let me write N, 35. Okay, that's sample size 35. Has a mean reading score of 82. So it won't allow me to put X bar here. So I'm going to get it from the other workbook. X bar is 82. I'll get it from here. So I'm going to have this formula. X bar, that's the sample mean. X bar. Let me make it big so that probably 18. X bar is 82. 82. So I'm going to copy it from here. Okay, and paste it in our main workbook. X bar is 82. Okay, sample mean. And the standard deviation is 15. Delta, which presents the standard deviation, is 15. Delta is 15. Then you're asked to find the 95% confidence interval of the mean. So let me write these values down. I got sample size is 35. Sample mean X bar is 82. Population standard deviation is 15. And the confidence level they gave you is 95%. Okay. So let's go and do it and put it in Excel and do this. So you go to Excel. So I'm going to take you up where I have this note. Say sample mean S bar is 82. Standard deviation is 15. Sample size is 15. Is 35. Confidence level given to you is 95, which is 0.95. Okay, error margin. Let's find the error margin. Remember that the error margin, we are given this formula for it. Z alpha over 2, which is the critical value, times standard deviation over root n. Like I said, but we're using the Excel formula, so we don't have to worry about that now. So let's do it. Once you find the error, and that's it. So we have error. To find the error, this is the formula we'll be using. I'm going to write it on the screen so you can see it. So I'm going to put it right here. Okay. Equals, do I put it on the paper? I'm going to type it in so that we remember this. Confidence, excuse me, dot norm, because this is for Z value. Then alpha, comma, then standard deviation standards, standard deviation, deviation, comma, then the sample size. Sample size. So for alpha, just use 1 minus alpha because it gave you 95%. So that is 1 minus alpha. Because if you're 95% confidence, your alpha is your chance of being wrong, which is 5%. So that should be 1 minus alpha. Let me make this into be probably 16. I'll make it bigger. That's the formula right there. Okay. So let's do it. This is 95%. I wrote 95%. Okay. So let's do the error. This is for finding this formula is for finding the error margin. Equals confidence dot norm. Now, like I said, for alpha, use 1 minus. For this, use 1 minus alpha. Sorry, 1 minus the confidence level, which is 0.95. I made a mistake again on the confidence. Let me correct it again. It's 95%, so which is 0.95. Okay. Good. Equals norm dot confidence dot norm. Yeah. Use 1 minus confidence level, comma. Then next one is the standard deviation. You click on it, which is right here, comma. Then sample size is 35. Click on it. Excuse me. Then close it. Press the enter key to give you the error margin. So with that, we can now get our lower and upper intervals. For lower interval, this is how the formula we use. Since this will not allow me to forget the X bar, I'm just gonna use what I have. I'm gonna write it as S bar. For the lower interval, use X bar minus the error margin, that we just calculated. And for the upper interval, use X bar plus error. So that will help you to get this out of the way. Make it 16. And make it bold. Yeah, no. Let me move this one down a little bit so I can have enough room for this one. Okay, that's it. So now, that means the lower interval we do equal S bar, which is mean right here, 82 minus this error. Laggy quantity. And then for the upper interval, equal, put 82 plus the error again. So this is what we got. Yeah. So make it round it to 2 decimal places or even 1 decimal place. But make it 2. So I'm gonna copy this. I'm gonna make it look good. Then copy it and paste it so we can finish answering the question. Our book where it says, part A says, find the 95% confidence. I'm gonna paste this here. Okay, make it 18 results. 16 for 16 is good enough, I believe. Let me make it a little bigger. Okay, make it, So now we can now make a conclusion. Conclusion. This is our interval that we got the lower and upper. That's what we are looking for. So conclusion. We can say with 95% confidence that, remember, this is the reading score. I was trying to estimate the reading score of all fifth graders. So we can say with 95% confident that the average reading scores, of all fifth graders, I want to copy it, that the average reading score or mean reading scores. You must mention average. If you don't put the average, the answer this that means the conclusion is invalid. The average or mean reading score of all sixth graders lies or is between 7.03 to 86.97 based on the sample of 35 fifth graders. Now, does anybody have a question for me? Any question?
Oh, yes. Is this the classwork that is due?
No. I cannot do your classwork for you, ma'am. Not say classwork. Classwork is what I give you to do, okay? I'm just teaching the concept.
I know,
What
but
will we be
classwork
doing
is
for
due
classwork?
today.
No, don't worry about that one. I'm not giving it out today. So just don't worry about it.
Okay.
Focus on getting, understanding the concept and also on the homework that is due on after this, on Sunday, I believe. The classwork I have to give it next week. Any other question? All right. Part B says to find 99% confidence interval for the mean reading scores of all fifth graders. Now, that's the good part of Excel. We have put all the formulas in. Now they'll ask for 99%. All we need to do is just to change the percentage and it will calculate the whole thing for us. So just go to the Excel and change 95 to 99. So change to 0.99. And watch this place, it will calculate it. See? It has recalculated it. So just copy it. Okay. And paste it in part B of the question. B part. Okay, and make it 16. Okay. Now, this is the lower interval and upper interval. Again, we can now conclude again. Our conclusion says so we can say with 99% confidence this time around, we can say with 99% confidence that the average reading score is for all fifth graders lies between 75.47, 75.47 to 88.53. Questions on this? No questions. Good. Excellent. Now, you can be asked this in a different form, like this is number 5. I'm going to bring it right here. It says, a random sample of number of farms in thousands in various states are as follows. They listed it. I think I have this on one of my books. Let me say, what are my notes? Sorry, it's yeah, 1 minute. Let me get it. So I'm going to type this in Excel. Yes, I think I have this list here. Make sure I have it here. Okay. Yep, I think I have it. Notes. It should be this one. Yep, got it. See, I have it on my notes. So it says, anyway, estimate the mean number of farms per state with 90% confidence. Assume that this we're not going to worry about the standard deviation. I will just calculate it. Okay. So now in this case, unlike this one where you are given the summary statistics in the question, you are given the mean and the standard deviation. This one you are not given those things. You have to calculate them by yourself and then follow the same process. So let's do it. First thing is to enter this number on the Excel. That's why I'm looking for where I have it on my notes. So I'm going to type it. I'm going to take you to Excel. Well, I'm looking at the next question. Sorry, my mistake. Yeah, if you ask this in this form. Okay. Which reminds me, I think you didn't see this part when I concluded. The last part, B part of these questions, I copied and pasted it here and highlighted the upper and lower. So with this case, we have that we can say with 99% confidence and the average reading scores of all fifth graders is between 75.47 to 88.57. Now, we are given this question in this form. Okay? Where they listed the numbers. We are not given, it's a random sample of number of farms in thousands in various states are as follows. So they give you a list of numbers. And you're asked to estimate the number of farms per state with 90% confidence. This case, unlike this one where they give you the smaller statistics in the question, the mean and the standard deviation. In this one, they didn't. They give you a list of numbers. So to do this, you have to calculate the mean and the standard deviation by yourself in Excel, and then go from there. Let me put these numbers in Excel first of all. We got take you to Excel right here. What is this? Oh, this one we did. This one we did. So I'm gonna use a different Excel workbook so we have enough room. So we have these numbers. We listed them here. 47, 8, 68, 95, 90, 7, 54, 3, 15, 33, 49, 21, 64, 4, 52, 4, 44, 6, 8, 79, 78, 57, 80, 109, 9, 48, 40, and 80, 16, 50. So let us find the mean and the standard deviation first. We need the mean, x bar. We need the standard deviation. Deviation. Okay. S. So we have, let us get them. With that, we can just get our confidence level. This is one way of doing it. Anyway, let me put this paper back. Put it back. So you can have this mean, because you know that the mean equals average. Okay, yep. Average. Average. It pops out, double click on it. Then highlight all this from the beginning, from the first one to the last one. Press the enter key. Make sure you highlighted all of them. Press the enter key. That means right there. Standard deviation is equal ST DEV because it's a sample. So dot S. It will pop out here. Double click. Again, highlight all of them. Press the enter key. That's 1.68. Now with this, we are ready to do the confidence interval for this. So let me just get this part of it. This part of it, sample mean. Now, another good thing about Excel, since we have done it before, the formula will just populate. In any case, I'm just copy only the one side, this side. Okay. Put right here. Then here we can have the mean we have is right here. The mean. And the standard deviation we have equals this one here. So I'm gonna, highlight this to make it good. And again, once again, I'm gonna go and get the formula so you can have them on this workbook as well. Okay, I'm gonna bring it closer. So we will be looking at it as we do it. I'm gonna also get the other formula, this one here. And then paste it here so you can as well see that one. Good. So the sample size, because it says in the question, how many, a random sample of how many farms. So you can, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 31 farms. If you add this one, 31 farms. So sample sizes, 31 farms. Okay, 31 farms. And just anyway, confidence level is this time around, it says to use 90%. So we're gonna have 0.90, 0.9, just 0.9. 0.9 is good enough. 0.9. So error. To find the error, we use this formula again. Remember, we will have copied the whole thing on that side. Just put the numbers. It will recalculate. But I just want to show you the formula again. Equals confidence. Click on here. All right. Click on here. Equals. Let me make it extend it a little bit so that you can have enough room. And bring the formula close to that under it so you can be looking at it. Equals confidence dot num pops out, double click. Alpha, use 1 minus the confidence level, which is 0.9, comma. For the standard deviation, use click on the sum right here, comma. Sample size 31. Close it and press the enter key. That's the error right there. So we have a confidence error. So now we can now do the upper level, upper interval and lower interval. So I'm gonna move this here. X bar minus error for the lower interval equal X bar, which is mean, minus error of this. Press the enter key. Gives the lower interval. For the upper interval, X bar, which is right here. Okay, plus the error here. So this is what we are looking for here. And I'm going to make them to be 2 decimal places. I'm gonna copy the whole thing. Control C. Okay. And then go to our main workbook and paste it so we can make our conclusion. Okay. Control V right there. Make it right here. Make it to be 18 or 16, as the case may be. Make it. This is. Let's just make this. This is the answer here. So lower interval is 34.57, 34.57. Upper interval is 53.29. So conclusion here is that we can say that we're confident that that the average number of farms, with 90% confidence that the average number of farms is between 33. Oh, how do I get 33? Maybe my rounding is too high. Let me double check my work here. Make sure I have everything correct. 43.9. Excuse me. Yeah, it's correct. It's just I think it's typo. Okay. So it's between 34.57, yeah, which is right here. 0.57 and then 53.29. Yeah, 1,000 farms. So we can say with 90% confidence that the average number of farms per state is 34.57 to 53.29 thousand farms. So that's how we do confidence interval for the mean for large samples. Now, if you're asked to find the minimum sample size, this is the formula we use. And Z alpha over 2 times the standard deviation by error squared. So let's do this one here. In this case, we are asked to find the sample size. So one example, let me make it 18 in size. So it is desired to estimate the number of chocolate chips per cookie, a large national brand. How many cookies will have to be sampled to estimate the true mean number of chips per cookie within 2 chips with 98% confidence? assume that the standard deviation is 10.1 chips. Remember, this is the formula. N represents the sample size we are looking for. Z alpha over 2 represents the critical value. Delta represents this population standard deviation, and E represents the error. Then you square it. And so that's the formula we'll be using. So if let us list our values here. In this case, this standard deviation is 10.1 chips. Okay. And error is 2 chips. E was 2 chips. If there's going to be a mistake, it's going to affect only 2 chips. Excuse me. And the critical value is Z alpha over 2. That part. Z alpha over 2. Because it's 2 sides. Equals for 98%. Remember, I showed how to get this. If you still remember the formula that we used, let me show you. We did it actually. I'll get the answer. Let's just go and put that answer from that book. For 98%, we got it as 2.33. 2.33. So I'm just gonna go and put it right there. 2.33. So this is all the things that you put in the formula here to find the sample size, the minimum sample size. Let me write them down and we can go and get them, put them in the other workbook, the formula in the other workbook, and then N equals Z alpha over 2 times standard deviation over error squared. Where Z alpha over 2 in this case is 2.33. Standard deviation is 10.1 and error is 2. Yeah? Error is 2. Excuse me. Let's go there and put this. Yeah. So we're gonna have sphere and okay, let me see why it's doing it. No. Okay, good. And let's go this more n equals. I put this. I'm gonna put make it squared, and I'm gonna put it around it. So I got Z alpha over 2. Z alpha over 2. Z alpha. Why is that alpha? I'm gonna find it right here. Alpha over 2 times standard deviation over error squared, which is equals, okay, and then put it in parentheses. For the alpha over 2, we have 2.33 from our distance. 2.33 times standard deviation of 10.1 over 2 squared. Yeah, let's put it in. We go to calculator. Clear equals 2.33 times 10.1 over 2 squared, giving 138.45. 138.5. Let me write it down. 138.45. So let's go and put it right there. 138.45. So let's copy this and paste this in the memo book. Yep, right here. So we have it right there. So we need now with this answer, if you have a decimal, just go to the next whole number. So because the question was how many cookies to be sampled? We should sample 139 cookies. Because you round it to the next whole number. Okay. Let me listen. Okay. We should sample. Make it 18. We should sample 139 keys. So now that's how we get the minimum sample size. You get the answer and you round it to the next whole number. You know that in algebra, this should be 138, but that's not what we're not doing the regular rounding. Just going to the next whole number. So that's how you find a minimum sample size. Any question on this? Any question? Hello, scholars. Do anybody have a question for me before we round up?
No question.
So now you can practice, use it to practice number 7, 8 as a practice. When we come back on Thursday, we start from confidence interval for the mean for when the sample population standard deviation is unknown and the sample size is small. Enjoy your day, and I will see you on Thursday. Okay.
Have
All
a
right.
good day,
All right,
Professor.
Professor. I hope you enjoy the rest of your day too.
You too. Okay. Bye-bye. All right.
Professor, did you take attendance?
Yeah, I was writing this as you guys are coming in.
Okay. All right. I had a question. So I remember you said if our attendance is how we can like reduce certain things. So is that gonna be like by the end of semester or like?
I don't understand your question. Can you ask it again? Say it again.
I remember you thoroughly said that by the that we can reduce certain things that we
Oh,
messed up on.
you mean the makeup time?
Yeah.
Yeah, if you have a 60% attendance, you can request for makeup, but that should be, let's start about that on Tuesday.
Tuesday?
Yeah.
Okay. All right. That's cool.
The other time, bro, you send me the email and the list of 5 assignments, not more than 5.
Okay.
That you would
All
like
right.
to make up.
Okay.
Yes, not more than 5. And then we go from there. But before you can make that request, make sure that you have up to 70% attendance. Cascades. If you're not up to 70%, there's no point to ask. Then you have to wait for your attendance to go up before you can qualify. Okay. All right. So I'll see you guys on Thursday.
For the makeup work, do we have to email you in advance?
For next week, you can send the email from Tuesday.
So email you before Tuesday, and then in person we can talk about making it up.
You can email me on Tuesday, and then I will check your attendance. If it's good, I'll get back to you with the makeup work.
Okay. All right. Thank you.
Welcome. Okay, I've seen it.